There are countless stars outside our galaxy, but this one is unlike any other. The first close-up image of a star outside our galaxy shows a red giant that is 2,000 times larger than our Sun. The sight of this monster is now revolutionizing science. It is 2,000 times larger than the Sun and a scientific sensation. About 160,000 light-years away, astronomers have discovered a red giant star that they spontaneously and with good reason named Behemoth. Red giants are bloated stars at the end of their lives. This phenomenon is not that rare in the universe, and yet WG64 is unlike any other. The first close-up of a star outside our galaxy reveals not just an unusual star but one of the most unusual red giants scientists have ever seen. The star is at home in the Large Magellanic Cloud. This neighboring galaxy has been accompanying our Milky Way for billions of years. The Magellanic Cloud contains about 30 billion stars. Its shape is irregular, and it's thought that this galaxy is the result of an earlier interaction with the Milky Way or the Small Magellanic Cloud, which has changed its original structure. Scientists even suspect that the Magellanic Cloud could merge with the Milky Way in a few billion years. This merger would change the structure of the Milky Way once again. New star-forming regions would emerge, and the upcoming merger with the Andromeda Galaxy could create a fascinating dance of three merging galaxies. WG64 will probably no longer exist by then. The giant star will explode in a few thousand to 100,000 years. Sensational image thanks to new technology. What makes a giant star a monster? Is it its sheer size, the boiling hot inferno raging on its surface, or the difficulty scientists have in studying it? Scientists call red giants behemoths, a reference to the Book of Job in the Bible, where behemoths are described as gigantic, fearsome creatures. Behemoths are not only strong and large but also bearers of extraordinary divine creation. On one hand, the sheer size of this star is fascinating. On the other hand, so is the violence with which this star will burn up in the not-too-distant future. During the time when the star has blown itself up to become a red giant, it will burn everything around it. If WG64 once had planets in its vicinity, they will have been swallowed up by the star in a long process of growth. So truly epic and biblical dramas are taking place here. It's estimated that in about 4.5 billion years, our Sun will also start to swell and gradually absorb all the planets. Fortunately, this point in time is reassuringly far in the future. It's much nicer to observe such a spectacle from a safe distance than to experience it on our own cosmic doorstep. WG64 has been known to researchers for quite some time, but until now, it was not possible to get a close-up of the star and thus learn more about the processes on its surface. This has now been achieved thanks to the development of a completely new technique. Gravity is a new instrument at the European Southern Observatory's Very Large Telescope Interferometer in Chile. The VLT interferometer, VLTI, is one of the most advanced astronomical instruments in the world. It combines the power of up to four 8.2-meter telescopes with up to 4 additional smaller auxiliary telescopes. With these so-called unit telescopes and the extensions, the VLTI creates a single virtual telescope that provides unparalleled resolution. If we were to put together all the individual parts of the telescope, we would have a telescope with a diameter of up to 200 meters. With this technique, researchers are once again achieving unprecedented precision. With gravity, researchers have now increased the telescope's capabilities even further. This groundbreaking instrument uses interferometry to combine the light from all the telescopes. With gravity, Astronomers can observe stars and planets with an accuracy of a few millionths of a second of arc. This precision is roughly equivalent to being able to see the wings of a butterfly on the Moon from Earth. Gravity has now provided the first close-up of WG64, and the data is stunning. Close-up reveals surprising insights. What do researchers do with a close-up of a giant star 160,000 light-years away? Quite simply, they meticulously analyze every tiny speck of light to find out everything there is to know about that star. The human urge to explore is truly unique, and so we use every technology available to us to unlock all the secrets of the universe. Think of it this way. Scientists can break down each pixel of such an image into dozens or even hundreds of pieces. Special spectrometers and computer programs analyze the recognizable light traces and, like detectives, can read incredible details from this information. Long-term observations of WG64 have shown that the star's light has dimmed over the past 10 years. Now, finally, researchers can find out why this is happening and what connections exist to the star's life. Gravity technology allows researchers to observe the star in real time and document processes in detail. Researchers warn that WG64 is so far advanced that any major change could be a harbinger of its explosive end. Unlike, for example, Betelgeuse in our own galactic neighborhood, this red giant has already begun to shed its outer parts. The star is already falling apart, and the egg-shaped ring seen in the photo consists of this ejected material. The shape of the cocoon fascinates scientists. So far, no computer model or simulation has been able to explain how this unusual shape came about. There are physical forces at work around WG64 that we don't yet fully understand. Since the star's light is already weakening, researchers fear that further close-ups will soon be impossible. The researchers are planning to upgrade the technology in the Atacama Desert specifically for this purpose. Imagine that observing a star like this one is of such great value to science that no effort or expense is spared to examine this star in detail until the very end. Is it possible that WG64 will offer a unique opportunity to watch a supernova live in the near future? The Large Magellanic Cloud, a cosmic jewel. Let's take a closer look at the location of this spectacle. WG64 is part of the Large Magellanic Cloud, an impressive neighboring galaxy of the Milky Way. It is located in the constellation Dorado, or Swordfish. If you look up at the night sky, you can see the Large Magellanic Cloud with the naked eye. It appears as a small misty spot in the southern night sky. It was named after the Portuguese explorer Ferdinand Magellan, who documented the cosmic nebula during his circumnavigation of the world in 1519. At that time, explorers had no idea that they were seeing thousands of other suns and even entire galaxies in the night sky. The Large Magellanic Cloud is in our immediate vicinity, at a distance of about 160,000 light-years. It's considered a satellite galaxy of the Milky Way. The Magellanic dwarf galaxies are probably gravitationally bound to the Milky Way. Structures seen in the interior of the Large Magellanic Cloud suggest that the galaxy is on its way to becoming an elliptical bar spiral galaxy. At the moment, however, its shape is still very irregular and not nearly as beautiful as that of our Milky Way. The Large Magellanic Cloud also has a diameter of only about 14,000 light-years, which is small compared to our Milky Way, whose diameter is a full 100,000 light-years. A particularly beautiful feature of the Large Magellanic Cloud is the Tarantula Nebula. This star-forming region is one of the most active in the local group of galaxies. The Tarantula Nebula is so huge that it's visible to the naked eye as a bright patch. It contains young star clusters like our 136, home to some of the most massive stars known.